Hi guys, so today I'm going to be walking you through a tutorial about the aluminum air battery. By the end of this tutorial, you should be able to answer the following questions. What is an air battery and how does it work? What is an aluminum air battery and how does it work from a chemistry perspective? What are the limitations of the aluminum air battery? And what are the benefits of the air battery, sustainable use, and the burden on resources? So before we get into knowing what an air battery is, we have to understand what a flow battery is and what fuel cells are. So a flow battery is a rechargeable fuel cell. So all a fuel cell really is fuel plus oxygen makes oxidation products. In a flow battery, the electrolyte flows through a battery which converts chemical energy into electrical energy. In the textbook, it says these batteries can run indefinitely if they have an endless supply of electrolytes. And it's also good to note that in fuel cells, oxygen is the oxidizing agent that will oxidize the fuel. Now that we have that definition, we can identify what an air battery is. So an air battery is a type of flow battery that uses oxygen from the air to oxidize a metal. As long as oxygen is available, the battery will produce electricity. In this tutorial, we will be mainly focusing on a commonly used air battery called the aluminum air battery. And this is mainly the most common air battery that you can commercially find. The aluminum air battery is mainly composed of an aluminum alloy, air electrolyte, and an electrolyte. So the aluminum air battery can power electric devices in commercial vehicles, and it can do this at a relatively low cost. And we will be going more in depth into why it can do this in the next slides coming up. Now, the big question is how can they do this? And they do this by producing electricity from reacting oxygen in the air with aluminum. Now, how does this work? So this battery uses the oxidation of aluminum at the anode, and the reduction occurs at the carbon air cathode. NaOH is the electrolyte that is circulating through the battery, and the NaOH present has high concentrations of OH ions. And the electrolyte circulating the system provides the electrolyte to the aluminum air supply and plays the role of the product of the reaction and the temperature regulation. Now, you probably can't visualize this very well because we don't have a reaction, so in the next slide, I am going to be giving the reaction and explaining what is happening each step. So the cathodic reaction is oxygen plus water plus electrons creates the product of OH ions. The second reaction is the anodic reaction, which is aluminum plus hydroxide ions makes the aluminum OH4 plus 3 electrons. Now, I outlined the key things that are happening for both the oxidation and reduction half reactions. So for the oxidation, the aluminum electrode, which is the cathode, reacts with the hydroxyl ions of the electrolytes, which then generates AlOH4 and releases electrons. And for the reduction reaction, these electrons flow into the air electrode and then they react with the water to generate hydroxyl ions. Now, if you add these two reactions up and balance them evenly, you will get the overall reaction, which is below. Here is the following practice problem of matching the name with the area on the diagram of the aluminum air battery. I suggest pausing the video and completing this problem before seeing the solution. So here are the correct labels for the components of the aluminum air battery. And it's good to note that depending on the metal in the anodes, which is aluminum in this case, it has a very high energy density capacity on the operating load. And the aluminum air battery also consists of an air cathode, which is oxygen and water in this case, as well as a suitable electrolyte. And this electrolyte can typically consist of any of the following, which is sodium hydroxide, potassium hydroxide, or sodium chloride. Now, this is a textbook diagram, which is a very interesting textbook diagram because it actually outlines all the main components that go into the air battery and how it functions. Now, what the textbook said is the battery stays charged by getting fed chunks of aluminum and water into it, as you can see in the diagram, and the electrode is circulated outside the battery where AlOH3 is precipitated from aluminum OH4. And the aluminum OH3 is collected and can be converted back to aluminum metal in the manufacturing facilities. So there's actually a lot of benefits to using an aluminum air battery compared to a lithium-ion battery or some of the commercial products we see today. So some of the benefits are that the aluminum air battery has a high specific heat energy and a high energy conversion rate. So that means it can convert energy very fast. Aluminum is also one of the most abundant metals on Earth, so we do not have a short supply of it. And it is also very cheap, so it is easy to make. And aluminum has also one of the highest energy densities, which is extremely useful. And this is useful because the amount of energy stored in a given system or a region of space is very high. Aluminum is also extremely light, so packaging it and distributing it would not be very hard to do. And it is also lighter than most batteries we see today. And probably the most important thing of all, which makes the aluminum air battery very different from any other battery on the market, because it is environmentally friendly. And it does this because the only waste product is aluminum hydroxide. And aluminum hydroxide can actually be smelted back down to make more aluminum, and this cycle is sustainable. Now, the limitations of the aluminum air battery we do have to consider. So some of them are the design for the aluminum air battery has only been practical for non-rechargeable batteries. And this is because once the aluminum anode is consumed by its reaction with atmospheric oxygen at a cathode immersed in a water-based electrolyte to form hydrated aluminum oxide, the battery will no longer produce electricity. And like we said in the previous slide, it is possible to mechanically recharge the battery with a new aluminum anode made from recycling the hydrated aluminum oxide. But like we said before, it can no longer use the same hydrated aluminum and it won't take part in the reaction. The second limitation of the battery is how quickly it will lose its charge. And compared to other batteries on the market, like the lithium-ion battery, the battery will lose 80% of its charge if it has been unused and not switched on for a month. And compared to the lithium-ion battery, it will only lose 5% of its charge after a month of unused. Okay guys, that is all for today, and I hope you learned more about air batteries and aluminum air batteries and what they can be used for in the future.